Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0203, indicates there is a malfunction in the injector circuit, specifically for the number 3 cylinder of the Honda Civic models from 2016 to 2021. This trouble code falls under the Powertrain Control Module Fuel Injection PGM-FI system and needs immediate attention. The injector circuit is responsible for controlling the fuel injection to the engine, and malfunctions can lead to performance issues, higher emissions, or even engine failure. It is essential to verify this fault before proceeding to ensure accurate diagnosis and repair. Therefore, the troubleshooting process may require the use of a Honda Diagnostic System, HDS, alongside visual inspections and continuity tests to identify the root cause of the problem. Adhering to the outlined procedures will not only assist in resolving the issue, but also reinforce the reliability of the vehicle's performance. DTC P0203 signifies a malfunction in the number 3 cylinder injector circuit of the Honda Civic, directly impacting fuel delivery to that cylinder. This error can result in incomplete combustion, leading to reduced engine performance and increased exhaust emissions. The PGM-FI system, known as the Powertrain Control Module Fuel Injection, governs fuel delivery and injector timing. The injector for cylinder number 3 is generally located on the intake manifold, connected to the vehicle's wiring harness and controlled by the Powertrain Control Module, PCM. Precise timing and correct electrical signals are crucial for optimal engine operation, as any fault in this circuit can severely hinder the engine's efficiency. Identifying the root cause of DTC P0203 thus becomes vital for not only restoring engine performance, but also maintaining the vehicle's overall health. Several possible causes lead to the manifestation of DTC P0203. An open circuit in the wiring associated with the number 3 cylinder injector may occur, which results in a loss of electrical signal to the injector. This could be due to corrosion, wear, or disconnection of the wire leading to the injector or the Powertrain Control Module, PCM. Additionally, a short circuit to power indicates that a wire may be unintentionally making contact with the power supply, sending incorrect signals to the injector. Furthermore, a faulty injector itself is a potential cause. If the injector has physical damage or internal failure, it may not function as intended, resulting in the error code. Recognizing these potential issues is key in effectively troubleshooting and rectifying the injector circuit malfunction. A malfunction indicated by DTC P0203 can lead to several noticeable symptoms that impact the driving experience. One of the most pronounced symptoms is an engine misfire, particularly noticeable during acceleration or at idle. This occurs due to incorrect fuel delivery from the injector, causing uneven combustion in the affected cylinder. Poor acceleration performance is another symptom. The engine may struggle to gain speed since the cylinder isn't firing correctly. Excessive fuel consumption can also result from this issue, as the PCM may attempt to compensate for perceived lack of power, injecting more fuel than necessary. Another possible symptom is an increase in exhaust emissions due to incomplete combustion. Recognizing these symptoms early can facilitate timely repairs, ensuring that the vehicle operates efficiently and remains reliable. The first troubleshooting step for DTC P0203 involves verifying the vehicle's status by turning it to the on mode to initiate the diagnostic process. Following this, use the Honda Diagnostic System, HDS, to clear any existing DTC. This function helps reset the onboard computer and allows for a fresh start in your diagnostic efforts. After this, start the engine. In case it does not start, it is advisable to crank the engine for approximately 20 seconds. At this stage, you will want to check for any new confirmed or pending DTCs using the HDS again. If DTC P0203 appears, it confirms that the issue is still present and you need to proceed to the next troubleshooting step. If the error does not show up, it suggests an intermittent failure, indicating that the system may be operating normally at this time, but needs further inspection for possible poor connections or loose terminals at the injector or the PCM. For Step 2, begin by turning the vehicle to the off-lock mode before proceeding with any further diagnostics. This precaution ensures safety during the tests to be carried out. With the vehicle in off mode, use the Honda Diagnostic System (HDS) to jump the SCS line, a safety control system procedure that provides additional diagnostics. After waiting for more than a minute, disconnect the PCM connector number 1, 96P, to inspect the wiring associated with the injector circuit. At this point, check for continuity between test points. Test point 1 is located at pin number 14 of the PCM connector, and test point 2 is located at pin number 15. Continuity here is vital. If the signal travels as it should, then the INJ H3 wire and the INJ L3 wire are confirmed to be intact, allowing you to move forward with the process. If there is no continuity, you will need to investigate further for possible wiring issues. In this step, the number 3 injector 2P connector must be disconnected from the wiring harness to check the continuity solely within the circuit associated with the injector. Make sure the vehicle remains in the off-lock mode during this check. Then, you will assess the continuity between test points. The female terminals of the number 3 injector connector at pin number 2 and the corresponding pin number 15 of the PCM connector number 1, 96P. A successful continuity test indicates that the INJ H3 wire is functioning correctly. In contrast, if there is no continuity, you will need to repair any identified open circuit in the INJ H3 wire. It's essential to meticulously trace the wiring to find the disconnection point, as ensuring proper electrical flow is crucial in rectifying the injector circuit malfunction. Step 4 requires checking the continuity of the INJ L3 line. You will again need to keep the vehicle in the off-lock mode and ensure that both the PCM connector number 1, 96P, and number 3 injector 2P connector are disconnected. Next, assess continuity between test points, specifically examining pin number 1 of the number 3 injector connector and pin number 14 of the PCM connector. Similar to previous checks, a successful continuity signifies that the INJ L3 line is functioning properly. If this continuity check is confirmed, it is recommended to replace all injectors as a complete set to ensure uniform performance and reliability across the fuel system. If not, be prepared to repair any identified open circuit within the INJ L3 line. Ensuring proper injector functionality is pivotal in restoring engine performance. In Step 5, the focus shifts to checking for shorted wires, specifically pertaining to the INJ H3 line being exposed to power. As before, start with disconnecting the number 3 injector 2P connector and then turn the vehicle's ignition to the on mode for testing. With the vehicle powered, measure the voltage between designated test points, pin number 15 of the PCM connector, and a suitable body ground. If voltage is found, this indicates a short to power within the INJ H3 wire, requiring immediate repairs to rectify the short circuit. On the other hand, if no voltage is detected, it signals that the issue may lie elsewhere, allowing you to proceed to the next troubleshooting steps. Accurately diagnosing this short is vital for restoring the integrity of the injector circuit. The 6th troubleshooting step extends the shorted wire checks to the INJ-L3 line. Begin by measuring voltage between the same test points with the vehicle in the on mode. This time, you will compare the voltage between pin number 14 of the PCM connector and body ground. Detecting voltage signifies that there is a short to power in the INJ-L3 wire, which necessitates repairs to eliminate the short circuit and prevent further issues within the fuel injector circuit. Conversely, if no voltage is present, it would indicate that the wiring integrity is intact, permitting a progression to the subsequent checks to identify any underlying issues. Ensuring each line's safety and performance is foundational for operational effectiveness in the injector circuit. In Step 7, the emphasis returns to the INJ-H3 line, where the next measure involves checking continuity. To do this, turn the vehicle to the off-lock mode and ensure that both the PCM connector 1, 96P, and the number 3 injector 2P connector are disconnected. Measure continuity between pin number 15 of the PCM connector and a suitable body-ground connection. If continuity is confirmed here, it suggests that the INJ-H3 wire is functioning without faults. If there is evidence of a short, it will necessitate repairs of the wiring. If the INJ-H3 is confirmed to be operational, you proceed to the final checks or consider other potential issues affecting system performance. This careful, thorough checking process aims to ensure that all wiring within the injector circuit is sound before concluding the repair. The final troubleshooting step focuses on checking the continuity of the INJ-L3 line, similarly to the previous checks. Retain the vehicle in the off-lock mode and ensure that both the PCM connector number 1, 96P, and the number 3 injector 2P connector are disconnected for accurate testing. Measure continuity between pin number 14 of the PCM connector and a suitable body-ground connection. If continuity is confirmed, this indicates that the INJ-L3 wire is functioning properly. If there's a short found, repairs will be necessary to rectify the issue. Should continuity checks confirm that both the INJ-H3 and INJ-L3 wires are intact, it may be necessary to consult any authorized service documentation related to DTCs or symptoms. Additionally, consider substituting a known good PCM for further diagnostics, which can help clarify whether the PCM itself is at fault and needs replacing. After resolving the issue associated with DTC P0203, it's crucial to conduct a final verification to ensure the repairs have been effective. Start the vehicle and allow it to reach operating conditions while monitoring performance closely. Utilize the Honda Diagnostic System, HDS, to check for any newly generated or reoccurring DTCs that may suggest lingering issues in the injector circuit. Confirming that DTC P0203 has not reappeared is vital, as it indicates a successful resolution of the circuit malfunction. Additionally, observing enhanced engine performance, such as smoother operation and improved acceleration, can also serve as positive indicators that repairs have taken effect. Conducting these final checks and verifications is essential in reaffirming the system's readiness and reliability for normal vehicle operation. Preventive maintenance plays a critical role in avoiding issues related to DTC P0203 and ensures the longevity of the fuel injection system. Regular inspections of wiring leading to the injector and the PCM can help identify signs of wear, corrosion, or potential failure points before they become major problems. Keeping the injector performance in check by routine diagnostic assessments can ensure proper fuel delivery and engine responsiveness. Moreover, Maintaining clean and secure electrical connections is key to preventing intermittent faults that could lead to unnecessary troubleshooting in the future. Implementing a scheduled maintenance routine will not only enhance vehicle performance, but also provide peace of mind knowing that potential hazards can be mitigated efficiently. In conclusion, understanding DTC P0203 and following a detailed step-by-step troubleshooting process is essential for proper diagnosis and repair of the injector circuit malfunction in the Honda Civic. Effective diagnostics using the Honda Diagnostic System, HDS, empowers technicians to identify faults accurately and ensures that repairs are methodical and efficient. Each troubleshooting step is crafted to isolate potential issues systematically and to ensure that the root cause is addressed thoroughly. Additionally, performing regular preventive maintenance is critical in maintaining the health of the vehicle's fuel system and preventing future issues. Overall, staying proactive in monitoring and maintaining the vehicle will ensure its reliability and optimal performance on the road. Please like and subscribe to the channel. See you next time.